Welcome to Module 6 of Digital Forensic Essentials, and we're going to be looking at Windows forensics. So with Windows forensics, we're going to look at 4 major areas. Number 1, understanding the collection of volatile and non-volatile information. Then we're going to move into memory registry. We're going to examine cache. We're going to examine cookies and history in browsers. And we are going to examine Windows files and metadata. Let's start with collecting volatile and non-volatile information. So here we are in Windows, and Windows is very important because if you go to a desktop computer system in any company, small business, all the way to Fortune 100, you'll find desktops, laptops, full of Windows operating systems. If you go into the data center, you'll find Active Directory hierarchies, and you'll find Windows being used in the data center. If you go into the cloud, Windows is in the cloud. So it's a very much used operating system. So it's very important to understand how to do forensics with Windows operating system. So let's take a little bit of an introduction. So Windows, Mac, and Linux, yes, 3 most widely used OSs. And so it's probable that you're going to run into that. And so we need to uncover evidence in that operating system. And we're going to run a digital forensic examination of the operating system. If we want to be successful, we need to know the commands, the method to extract both the volatile and the non-volatile information from those operating systems. In this case, from Windows. Let's talk about collecting volatile information. This is information, as we were saying before, that if you turn off the computer system, it goes, it's gone, and it's hard to get it. It's impossible to get it back. It's going to be in registers. It's going to be in cache. It's going to be in RAM. You're going to get things like the system time, logged on users, open files, network status, process information, process memory. Look at all this stuff. Clipboard contents. If you do a Control-C and copy something to the clipboard, it's going to be in there. All the history of commands that you typed. These types of things are volatile, and we need to collect them. So let's take some time and go through a certain specific commands and techniques for gathering volatile Windows information. Let's start with collecting the system time. So when is it that we are actually looking at? What are we looking at in terms of time? There's a command called date/t &time/t that we can use and get information as to exactly what date and time it is. And by the way, I want you to know that we're going to be looking at commands for the most part in the command line, at the command line, cmd.exe. There are other commands that you can use that duplicate this, and sometimes they're a little bit more simple, sometimes they're a little bit more complicated, but that you can use with PowerShell. So, but these are going to be mainly command line, and we want to get the exact time and date, the process, what was the time and date we started, and that way we can have legal proof of the forensic investigation for the system. Next, we want to find out who in the world was currently logged on this system right now. For instance, let's say that you have a user, and the user's name is Fred. Fred uses this workstation, and he logs onto it every day when he comes to work, and he logs off of it every day at the end of the day when he leaves work. But Fred's computer is now part of an investigation, and as soon as we move Fred out of the way, we can type in PS logged on. And guess what? We might find that there's a third party, a remote party, or another local party, other people logged into the system because it's being attacked. And Fred wouldn't have even known that if he was not a part of the attack. So we use PS logged on. It's a little applet that shows the logged in users. And so we have the administrator here in this case. And it says users logged on via remote. Look at administrator. So there might be, so you might be surprised who's logged on to a workstation as a forensic investigator. And also we can use net sessions. And with net sessions, it gives us the computer and names on the system. And so we do net sessions. And again, we see both administrator logins and from whence they are coming. And furthermore, we can use the logon sessions tool. With the logon sessions tool, we can use the P option and we can find the sessions that are listed. So we can use -C and -P. We can print it out as a comma separated value file, delimited using specific delimiters, and have a list of all the running logon sessions. That's the logon sessions. You see the right there tool. See it beginning right there. All right. Next, we look at the net file command. And if you were just to open up a command prompt right now, or open up PowerShell right now on your Windows system, and then type in the word net, and then hit enter, you would see there are a huge number of net commands. We just saw net sessions, and now we see net file, and we do this to view open files. And so we want to see if there's an intruder that's using a remote login, get details of open files, ID, name, a number of file locks, and also look at individual shares. We can remove file locks, close shares, and this is net file. Let's do that as a raw command. You get ID, path, username, and any locks on the files. That's a net file. Also, another tool that we can use is called Network Open Files. It's a utility for Windows that shows you all the open files for the host of the operating system and the permissions and a lot of metadata about that. You can right-click on one of these and get the properties and have a layout of all the metadata for that open file. So you can use that to find open files. So we can collect lots of data about open files on the system using these two tools. Next, we look at network information. We want to find information about the network connections. We want to find out where incoming and outgoing connections. And one of the best built-in Windows tools is NetStat. NetStat-C is the contents of the cache, which is those named to IP. NetStat-ANO. There are so many different ways to use NetStat, and it gives us information about what is happening on the network. We can also, there's that ANO switch I was talking about before, where you get TCP and UDP connections. See this term established right down here? That means that the full TCP three-way handshake took place between the two hosts, and now they're exchanging information. So if you're not familiar with the TCP three-way handshake, it's something you should look up in DuckDuckGo or in Google and be familiar with the TCP three-way handshake. So that's what establishes, and that's really one of the major items that we look for is established TCP connections, and we can get that with NetStat-ANO. What about running processes? And so we can look at running processes. These are applications, programs. Every program needs at least one thread. It's called a thread to process, and whenever you have a thread, that process is assigned a process ID, and you can look and see how much CPU memory and other resources that process is making use of. If you do a Control-Shift-Escape, you'll get Task Manager. You can also right-click on the Windows taskbar and go to Task Manager. A couple different ways to get to it, and it has many different tabs. Specifically, though, you'd want to go over to the Details tab to get the most information out of processes. There is also task list. If you do a task list -V, you'll get a verbose listing of what each process is doing, what each PID is doing, how much memory it's using, the user that has spawned it, CPU time, etc. So task list, command line tool that can help you with processes, and plist, which gives you information about the processes running on a system. You can do the -X switch to show you memory information and threads. So if there's a multi-threaded process, you'll be able to see all the different threads of the process. Also, in many cases, not only do we want to see the process, but if it's being run remotely, it's going to be assigned to a port. So we might want to do the process to port mapping, and there's netstat anno again, which traces the port to the process and the protocol. And so we can see exactly where that process is being run. So for instance, if there is a remote hacker, an attacker that's running a process, we can see the executable and we can see the port through which it's running. And we can say, hey, that is a user, a remote attack, a remote process. Now, what about memory, process memory? So any running processes could be malicious. They could be suspicious. And as forensic investigators, we need to be suspicious about everything. What I like to explain to people, the difference between a network operations center and a security operations center. So in a network operating center, a router throws an error and it says, hey, interface 0 is down, no longer up. And the people in the network operating center might say, oh, that's an old router. I guess it went down. Let's see how we can repair it. The people in the security operating center will ask this, who attacked us? Yeah, we're going to be a little bit more paranoid, and we need to be suspicious of what's going on because we're investigating. We always have to be thinking about what's going on. Process Explorer is a really nice tool. Check if the process is malicious. Check if the process is suspicious. Look at the handles. Look at the DLLs. Look at those processes. If you find a process and it turns out that, oh man, this is actually kind of weird. This is something I need to investigate. Then you can use other tools like ProcDump and Process Dumper and go deeper into that. And if you can isolate the executable, the binary, then you can use VirusTotal to check and see whether anyone else has reported that as suspicious. All right, the next thing we want to look at is collecting the network status, IP addresses, subnet mask, DHCP, DHCP v6, DNS servers, etc. And so what we want to do is use commands like ipconfig, ipconfig/all, promise detect, prompt query. All of these will give us information on a couple of things. The ipconfig/all give us the network configuration status, and the prompt query UI and the permiss detect tool give us information, but they also show if there is a sniffer on the network. So those are important tools. And this is like what I'm talking about, looking for a NIC, network interface card, that's running in promiscuous mode, which might be a sign that, hey, there is somebody that's running Wireshark or some other type of sniffer on the network. All right, now let's talk about collecting non-volatile information. So this, like we said before, it's information that even if you turn down that system, it's going to be available. So if the investigatory target, the suspect, has been using Word documents, Excel documents, sending emails, storing data of various types, even if it's been deleted, we will be able to investigate that. And so that's going to be on the hard drive. It could be regular files that are unaltered, or it could be swap space, slack space, even an unallocated space. All of that is non-volatile information. Now, the investigation might actually include not just the hard disk, but related and maybe even unrelated, at least up to this point, DVDs, Blu-ray, thumb drives, flash drives, and even smartphone memory, the both internal and external storage inside the smartphone, plus SD cards, etc. So there's a lot to think about. So let's start with examining file systems. Now, if you can even try this if you want. You can open up a command prompt and you type in the word dir. just by itself and hit enter, and it lists out all the files and directories in that local area. But if you want to get more information about the file, we can do a dir/o:\d, and this will not just give us a list of the files and directories, but it will give us time and date of the OS installation, service packs, and you don't see it all here, but service packs, subdirectories, automatically update themselves, drivers, stuff like that. So we get a lot of information if we do the dir/od. And what we want to give priority to as an investigator is recently deleted files. That means that the perp is trying to cover his tracks. Now we also look at ESE. ESE is the Extensible Storage Engine, and it's a storage technology that is used in certain classes of database. And so if you're using Active Directory, good old Windows Mail, Windows Search, Windows Update Client, that a certain type of database I was talking about is known as JetBlue. In fact, you might want to go and have a look up in Wikipedia on JetBlue. There's a lot of interesting history to JetBlue and interesting applications in which it's been used over the years. But that ESE database, the file extension is actually called EDB. And so there are many different EDBs out there. For instance, if you have contacts in Microsoft Live products, that's contacts.edb. So it's a little database based upon the Extensible Storage Engine. You can have calendar items, messages, you have stores, cache, history, cookies. This is actually very interesting for anybody using Internet Explorer 10. That'll be in webcast-v24.dat and webcast-v01.dat, where you can find that. And then, of course, we have Exchange Server, Microsoft Exchange Server. In the mailbox database.edb in the public folder, EDB are other places where you can find information on Exchange servers. Windows EDB stores index information. When you have a database index, sort of like we were talking about with GUID partition table and the master boot file, what they do is they show you where everything's located in the database. We have database StoreDB, which is for Windows updates, and that's going to be in Windows WAC software distribution, WAC data store. And then we have Spartan EDB, where we find not just stuff for Windows 10, but Explorer 10 and 11. And this is going to be all of the favorites, and that's going to be under local data packages, Microsoft, etc., etc. We go all the way down here to data stored data, and we have a unique number for those favorites. So yeah, that's under your percent local app data percent, which is a location that has a lot of specifically application-based data. So if you want to look at this EDB information, one of the tools you can use is ESE Database View. And this is just a look. I'm going to zoom in on it for us here. And so here's ESE Database View. And we are looking, if you look at the path, we're going in the software distribution data store EDB. So we're looking at the data store EDB. And we see the object table, the type, the ID, the space usage, and any flags associated with that. And one of the things we can establish is if there's any discontinuity in the database structure, like for instance, a suspect tried to cover their tracks, etc. So we can use ESE View. We can look at extracting data from those EDBs, get evidence from them, look at all the tables and the records, and then extract that data, and then export it to an HTML file, which is actually really nice because then we can actually review it and it's more human readable. Another area that we'll find with the ESE data storage technology is Windows Search Index. Now, what Microsoft has done on their most recent operating systems is made it much easier to search the entire operating installation operating system installation, and that is through a file called Windows EDB, and that has the information on that Windows search index. And so with the ESC database view tool or other tools, you can parse the files that are stored in this index and look at information related to encrypted files, events, damaged disk, event bounding, get good metadata and other information for investigation. And so in this case, what we're doing is we're parsing the Windows EDB file and extracting details of deleted data on a system. So these are the details of deleted data, and that can help us to correlate that with other tools that we're using to find data in disks, etc. All right, now we look at what about externally connected devices? So there's a flash drive, there are external hard disks, and other types of external devices. And the reason these are used is because they can help the perpetrator, the attacker, hide what they're doing, because they can just take that flash drive or that external disk or the SD card or the micro SD with them and maybe not have any clue, if you just look at the normal operating system, that anything happened. So as part of our forensic investigation, we need to identify devices that were connected to the system and see if there's any suspect external media, and we can later examine that. So there's a really nice tool that we can see called Drive Letter View, and it views all the drives on the system, even if they're not currently plugged in. So the user plugged in a flash drive, and then they got the data, they exfiltrated it, and then they unplugged it. So, but we can still see it. So there was a Seagate portable SCSI device that was plugged in. It gives you the instance, it gives you the path, it gives you the letter that was assigned to it, and you can even get more information on the size and etc. And remember, this is irrespective of whether it's still plugged in or not. You can still get that information. Another area that investigators are going to investigate is going to be slack space. We talked about slack space before, and it's the space that is in between files. And so it's non-contiguous in partitions of the hard drive. And that slack space can contain information from previously deleted files. It's a space that is unused, meaning that it's unindexed. So what are we going to do with that? First of all, we're going to connect to that computer and select the media we want, and then we're going to create a bit level copy of the original media, and then we're going to verify the copy, generate a hash value, and then investigate using keyword searches, hash analysis, file signature analysis, and then scripts to present in the N-case tool. And one of the very nice ones we can use to look at that information is Drive Spy. Drive Spy is very nice. We'll see that in the labs. It's a tool that collects all the slack space in an entire partition, and it puts that slack space into a file that you can examine. That brings us into the next area for Windows data collection, which is performing Windows memory and registry analysis. So with Windows memory analysis, we have the ability to check RAM, random access memory, physical memory of a computer system, examining memory dumps, detecting hidden rootkits, looking for hidden objects, suspicious processes. So one of the tools of an attacker is to, for instance, get the user to click on a link to download a Trojan horse. It looks like one file, but in actuality, it's another file. It's malware, and that malware makes use of the user privileges, which in many cases the user is logged in as an administrator. And using that user privilege, we can install a tool that installs a backdoor or a rootkit on the computer system. Now, if you were to go to do a Control-Alt-Escape Control Shift Escape, excuse me, not Alt Escape. Control Shift Escape, and then go and look at your file IDs and look at every single process, the PIDs, look at the memory allocation that's being used, look at, you will not see that rootkit running at all. It is extremely stealthy. And there are many different ways that rootkits install themselves at a very low level. In fact, some rootkits even will install essentially a hypervisor that virtualizes the entire operating system of the user. And so the rootkit has extremely low level access. And then there are other ways to have that really low level access. So doing memory analysis can help detect those rootkits. So one of the things we can do is a Windows crash dump. Windows crash dump. If you look at startup and recovery in Windows, here's the startup and recovery information. But what I'm looking for is this. In a system failure, what are you going to do? Are you going to write it to an event log? Are you going to automatically restart? Okay, that's nice. But what about the debugging information? And so sometimes people will turn that to none, and there are reasons for that. But in this case, we do automatic memory dump. That's right. So it has all the contents of the memory at the time of the crash. Very nice for an investigator. You can diagnose bugs. That's the purpose of it. So you can do a crash dump analysis and find out why the system crashed, especially if a system is repeatedly crashing. And then as an investigator, you can use a little tool called dump check and actually look and examine that crash dump information. So that Windows 10 OS, it's going to create automatic memory dumps. It can do a complete memory dump. It can do a kernel dump. It can do a small memory dump. And then we use tools to examine that memory dump as a forensic investigator and find out why it crashed, what happened, was there a remote attacker, was there an exploit or a bug in the OS, was there a third-party application installed in the OS. We can get all kinds of information from doing a crash dump analysis. We can also collect process memory and do a RAM dump and then examine the RAM dump file. There's a process dumper pd.exe that dumps the entire process space with metadata and the process environment to the console, redirecting it to a file if you want, or even out of socket. And so a user dump.exe dumps any processes without, you don't even need a debugger, you don't need to terminate the processes. Another one would be addplus.vbs. It's a Visual Basic script. And then we have the dump that we've created. And then we can use debugging tools. And from those debugging tools, we can analyze the dump. So all of this is about getting that memory, getting random access memory, getting that volatile information. Examining that volatile information is as important as the non-volatile. So we want to examine RAM dumps, artifacts that we can find in there are running services, files, media, processes, network information, malware activity. In fact, this is one of the major things we do. In fact, a lot of this, when we do malware analysis, is we'll use some of these same tools and some of these same processes because we can go grab information, and anything that's running on the computer system, even if it's fileless malware, is going to be in RAM. And so if you do a memory dump, you can catch the fileless malware. If it's a backdoor or a rootkit, if it's actually running right now, it's going to be in RAM. So even if we cannot see any process ID or any trace of that rootkit, if we have the adequate analysis tools, we dump RAM, because that rootkit, if it's running, it'll be in RAM, and we can find it. So during that live acquisition, there are so many tools we can use. Some of the best would be Belkasoft RAM capture and the Access Data FTK imager. We see FTK in there a lot with a lot of really cool tools, and those will help us with that RAM dump. Another thing we want to do is, especially if the threat actor has been using malware, which we find that happens quite a lot, we'll use the malware analysis techniques that I was discussing just a few moments before. And one of the tools and methods that we use, the tools can be stuff like this one that we see right over here, which is Redline, which is a pretty cool analysis tool. And the method that we use is called memory forensics, right? So what we can do with Redline is find malicious activities, look for timeline, look for scope, analyze RAM, analyze the data, and look for all the processes running when the dump was acquired, and maybe see a process that we could otherwise not have seen. If we click on ports, we can look at the under processes tab, you find all the connections that were available when the RAM dump was acquired. And so in this screenshot, we're looking at rundll32.exe with the process ID of 1896, but it's making a connection that's been, look at that, what is that word? Established out to a specific IP address through port 4444. Yeah, I think that was 44s, which looks suspicious. We can find that because we have a tool like Redline to help with those memory forensics. All right, a construct that you will find uniquely in Windows and not in, like for instance, OS X or in Linux, is the Windows registry. And we need to analyze it as part of our forensics process. It's a hierarchical database that has low-level settings for Windows OSs, and virtually every application that you're going to use uses the registry, and helps with investigations, because we can go through all the registry hives and subkeys, etc., and track activity, even using timeline analysis. The registry has quite a lot of information in it, and every action that's performed on that machine is recorded in the registry, so it's a great way to get good intel on that machine. And so there are two major types of registry hives. One is non-volatile. So the non-volatile are HKey local machine and HKey users. And the volatile ones are HKey classes root, HKey current user, and HKey current config. And there's a lot to say about the registry. Some of these keys and some hives are cloned from volatile into non-volatile, and there's an exchange between these two. But either way, while that machine is running, we need to go ahead and collect that HKey local machine and HKey user data as part of our live analysis. So the hives in Windows registry, they are critical to how a Windows system functions. So let's have an overview of what the major hives do. Number one, HKey users, all the actively loaded user profiles for the system. If it's a standalone system, it's just going to be one usually, but there can be more. HKey classes root. This is a hive that has configuration information. So these are applications that are used for getting into and interacting with files on the system. We have HKey current. That's a little, this one current config, and current user tells us it is looking at right now, a slice of time. So it has the hardware profiles, and this is what we use for startup. This is what the system used for startup currently. And then one of the most busy and important hives of all time is HKey local machine. And this one has a lot of configuration information for this local system. So for instance, if I have a mouse, it's an HKey local machine. If I have the monitor type that I have plugged in, it's an HKey local machine. If I have settings for software, so if I change Windows, Microsoft Word, and I do a change, it'll probably appear in HKey local machine under a software location. So it has quite a lot of information in there about hardware and software settings. The next one, again, has the word current in it, and that is HKey current user. So it is the active loaded user profile that is currently logged on. And so what happens is it's cloned from HKey users, and then the specific information of the current user is added to that. So these are the main hives, and we have cells in the registry. These have specific structure and information. So one is a key. So what is a registry key? It's a type of cell that has offsets to other cells and last write information time for the key. What else do we have? Value. So that's a value cell. It has a specific value. So for instance, I can go to a key and then select that key. And then on the right-hand side of the registry, there'll be a value that I can change. And it will then be saved into the registry key, which will be saved into the Hive, which, etc. We also have a sub-key list cell. So this is made up of a series of indexes pointing to key cells that are all sub-keys to the parent key cell. And those also can contain values. So these are a series of index pointing value cells. These are all values of a common key cell. And you'll see some of this in the lab. So if this is kind of hard to explain without actually showing you in the registry, but you'll see it in the lab. And then we have the security descriptor cell that has security descriptor information. But where is it? It's in the key cell. So essentially what you see is we have keys and we have values. And they're located in different locations in the registry hierarchy. So in terms of forensic analysis, we need to be able to examine the registry. We have both static and live analysis of the registry, and we want to extract forensic artifacts. We want to know what was going on. Did somebody plug in a micro SD card, or was there a USB drive, or did they execute a program, or is there a newly installed application, or was there a file that was recently accessed, or are there files that were deleted or added? Did a user log in locally to a local user account? How many users logged in and when? Did they log in remotely to an Active Directory account? What happened? We can find a lot of that, if not all of it, through forensic analysis of the Windows registry. So with static analysis, what we're going to do as an investigator is look for the files that are stored on the captured evidence file that's going to be located in Windows System 32 config. But for live analysis, we're going to need the built-in registry editor or tools like FTK Imager to capture the registry files from the live system and then analyze them that way. So here we see that we are going to be using the regular registry tools in Windows, or in this case, we're using FTK. And so in FTK, we go to File, Obtain Protected Files, and we can do password recovery or all registry files. This is what we have here. And then we provide the destination where we want to extract those files. Great tools for the registry. And so as we conduct that analysis, like for instance, I was talking about all of the amazing items that you can find behind HKey local machine. And those would be SAM, which is Security Account Manager, all the local security database subkeys for the SAM. This is if you log on to a Windows system locally, you'll have the SAM database. We also have a security, so HKey local machine security. That is the local security in the SAM database. HKey local machine software. This is a place where you will go quite a lot. HKey local machine software current control set is one of the paths you'll follow quite a lot. But this is information about the software apps system, is information about settings of hardware and services. And then we have default, which is the user settings that have the currently logged on users, but ntuser.dat, that's where we get these settings. But this default is for the currently logged on user, and it overwrites the default setting. So this is a current thing for that person who is logged on right now. All right, so let's do a little zoom in on here because you'll find this pretty interesting here. This is extracted information, forensic analysis of the registry, and we see that we have information extracted related to software installed. So we have TechSmith, which makes Snagit, and we see that's the executable that was running. Isn't that interesting? Program files, x86, TechSmith, Snagit is what we found by examining that registry location. Also, we can examine registry information by using Hex Workshop and grab really interesting information from that tool also. All right, now let's have a look at examining cache, cookie, and history in web browsers. So what's going to happen is if you have an insider, or if you have a criminal, or you have whatever it is that we're investigating, very often they'll be using a browser. And what they're going to try to do is anti-forensics. They're going to try to hide their history and so on. So you need to know where everything is located. In many cases, there will be no anti-forensics, and you'll just be able to walk through the cache, the cookie, the history analysis of the browser. So you need to be able to examine browsers like Microsoft Edge, Google Chrome, Mozilla, Firefox, Brave, Cake. Actually, Cake is going to be on mobile devices, but there are many different browsers that you'll need to be able to go through. Web history, cookie, cache information, getting to that browsing activity that we're looking for. So in Google Chrome, very popular browser in Google Chrome, if you want to look up cookies and history, it's stored over here. Look at it. Look at this. The user, and under app data, local, and then from local we go to Google, and from Google we go to Chrome, and from Chrome we go to user directory default, and that's going to be our history. So if you look at, let's go ahead and zoom in on this up at the top, and we see that we are in user data default. We go down into cache. There's a lot of information, and here's our cookies stored, and there is what we were talking about just now, history. So, and there's a lot of other stuff in here, but we can't go through all of it. Then there's the cache location, and we see in Google Chrome, WAC user data, WAC default, WAC cache. So much information we can find and analyze. There's a very nice tool to help out with this, which is Chrome Cache View. And it's a nice little lean utility that goes through the cache folder of Google Chrome, looks at all the files currently stored there. You get URL, content type, file size, when it's going to expire. That's important right there. The server name that was contacted, the response. That's a lot of good information. You can get that from Chrome Cache View. Another analysis tool is Chrome Cookies View. And this is where you can list all the cookies that Chrome has installed in the system. And you can export them if you want to a comma-separated value file, or XML, or HTML, or text, or whatever you want, so you can examine them further. And so you get lots of stuff in here. You get host name, you get path value, HTTP, last access time, expiration time, and a lot more for each cookie. But wait, there's more, because there's another tool that can help you out, and that's called Chrome History View. With Chrome History View, it reads the history data file of Chrome, gives you all the visited web pages, and it gives you days worth of that information. And you get the URL, you see right here, you get the title, visited on, visit count, the address to refer, the visit ID, the number of times the user typed the address. Wow, lots of information there. So that's some really good tools that we can use for Chrome. What about other browsers? Not everybody uses Chrome. Well, we have Mozilla Firefox. And again, you can get cache, cookies, history out in username, app data, local Mozilla, out in Firefox profiles under the unique number default, cache to, or under profiles, unique number default, cookies, SQLite, or under the profile, unique number default, places. So that's cache, that's cookies, that's history. How do you examine this information? Well, there are tools. There are tools for that. MZ Cache View, MZ Cookies View, and MZ History View. And I want you to know that most of these coming from nearsoft.com, and this one here, Cookies View, is coming from Zimporium.com. What about Microsoft Edge? Edge is becoming, it's one of Microsoft's browsers, especially the Chromium-based version, and it's actually gaining traction for the first time in a long time because Microsoft Explorer was really losing audience. But again, we need to capture the history and make use of it for Microsoft Edge. We want cookies, we want cache, we want history, and we'll find it not HKey, I'm thinking of the registry. Users, whack admin, app data, local, Microsoft Windows web cache, or packages, Microsoft Edge, or local Microsoft Windows history. See all these paths? Oh yeah, and there are tools to help you examine the information that you find in these paths, including IE cache view from Nearsoft, Edge cookies view from Nearsoft, and browsing history view again from Nearsoft. So they make a lot of browser tools that you can use right there at nearsoft.net. All right, now we're going to look at examining Windows files and metadata. So what about Windows files? I tell you what, we need them. We need to find out what's going on with those, what the user was doing. We want MAC timestamps. We want date, time, size, number of times the application has been run, process name. We get all that information. We also want to see if something was installed or uninstalled, deleted, changed. All of that gives us good intel on what was going on with that file. So one of the areas that really helps Microsoft Windows, specifically Windows 10, to be resilient is the system restore points. And so if you've never used one of these, it's very interesting because let's say that I go get a piece of software and I double click on pdq.exe and I install the software, and then my computer starts acting strange and it blue screens or it has trouble or it slows down or whatever. If I have restore points turned on, what's happened is there's been system data that's been recorded over time. The last restore point, guess what I can do? I can restore my system and roll it back to the last restore point. I will no longer have that file, that executable that I installed, and the system will go back to the stability level of the latest restore point. So wait a minute. So you're saying there's a lot of system information just waiting for an attacker or an investigator? Yeah, that's all in the restore point. So first thing we want to do with restore points is go to the RP log file. So it's the restore point log file in the restore point directory, and it has a type of restore point, description name for the event that triggered the restore point, the 64-bit file time object when the restore point was created. So yeah, when are these created? You can trigger a restore point if you want, anytime you want, if you have it set up. It's also created when an application or unsigned drivers are installed. So I have an application, let's say I go buy a widget, and this widget connects to my computer and it requires a driver. There is not a Windows driver for it, so I use an unsigned driver from the organization that produced the widget that I've plugged into my computer system. Then Windows is going to say, wait a minute, this does not have a digital signature on it. It's a driver. It can cause a system instability. So before I install this into my system, let me go ahead and copy the system the way it was before the silly user installed this widget onto the computer system. And so therefore, when the computer system starts acting all wonky, we can go back to the restore point. Make sure you unplug the widget first. We don't want that thing to do anything bad to the system. So so when you have an unsigned driver, your system will run a restore point. So unsigned drivers and auto updates. And of course, you can trigger it yourself as a user. And so there's a description. You can add that in. Usually that's automatic because most restore points are automatic. And so, but it'll tell you that this restore point was created because of an unsigned driver, or this restore point was created because of an update, or the user triggered the restore point creation. Now, there's also another area in restore points called change.log.x. So these are changelog files, And these are in restore point directories. And so they are monitoring all the files that are detected by the restore point system driver. And the original file name is entered into that change.log along with sequence number, type information, etc. So this file is monitored, it's preserved, it's copied to the restore point directory and renamed a something or other, a kind of random series, .ext, where these X's, again, are sequence number, and ext is the original file extension. So that change.log file is appended with a sequence number, and a new change.log file is created when the system is restarted. So that's another area to investigate when we're dealing with investigating restore points. All right, what about prefetch files? So if I were to install an application, I run it or I delete it, the traces of what the application was doing and what it was, those can be found in the prefetch directory. There's a dword value offset of 144 within the file that corresponds to the number of times the application was launched. So you can tell, like for instance, I guess an application that's launched quite a lot on most computer systems are browsers. So we can look at that dword and find out if you look at that offset value 144 or 120, which is the last time the application was run. Right? So that's going to be UTC format. And so we can grab information from that PF file, correlate it with the event log, correlate it with the registry, correlate it with our SIM, the SIEM system that's taking in all logs from everywhere and really help to know what's going on. We find out who was running the application, if it was local, if it was remote, when the application ran, when it stopped, when it was closed. All that information is in the prefetch file. So if you're wanting to do that, it's located in the registry where we can control that. So it's used by this. Why do we do prefetch? To speed up the boot process. So we can prefetch data and speed it up. So the data is recorded for up to 10 seconds after the application is started. And it's in Windows Prefetch where we can find it. And an HKey local machine, current control set, control session manager, memory manager, etc. Yeah, you know, I think I had talked about HKey local machine software current control set earlier. It's actually system current control set that I was talking about. So just to go back to the registry hives, but either way, it doesn't matter that much. Now, what we see here is we have the enable prefetcher, and we can set settings on this by double-clicking on here and changing that reg dword. 0 is, there's no prefetch. 1 is prefetch is enabled. 2 is boot prefetching is enabled. And 3 is if you want prefetching enabled on both boot and application, which in normal operations should speed up your system. What about image files? So there is metadata.